remnants of a time before the sun sparked into life. Planetary scientist Dan Durder believes this water had little chance of survival on the newborn Earth, thanks to the heating effects of multiple high-speed asteroid impacts.
Building a planet is a very violent process. We can demonstrate pretty easily here with the high-speed impact of a bullet. Okay, so that's a single impact.
When the bullet punches into the target, some of its kinetic energy is converted into heat. You can see this sudden hot burst using a thermal imaging camera.
In the case of a real impact, a large asteroid impact, the energy is a lot greater. You're actually melting rock. And 4.5 billion years ago, impacts like that were happening once a month. Let's go see what we got up there.
A submachine gun demonstrates how this heat would have built up after multiple asteroid impacts.
The cumulative effect of all these impacts is to heat the surface of the Earth to near magma, lava-like temperatures.
The combined energy of the impacts boils the surface of the young Earth.
There's a lot of impact, and it's a very high temperature activity. So any water that would be present, it would be hard to hold on to it because of the heat and the energy. The water probably escaped.
After 60 million years, the planet building stops, and Earth's surface cools enough to form a crust, potentially trapping any remaining water inside it. But not for long. The crowded early solar system is home to more planets than exist today, and one, known as Theia, hurtles towards Earth. Smashing into Earth, Theia gouges out a huge chunk of our planet's crust. The rocky fragments create a colossal ring of debris that will eventually coalesce to form the Moon. Reeling from the impact, Earth reverts to a ball of lava, and the heat drives off yet more water. The collision with Theia leaves the crust of the Earth bone dry. So where does the water that we see today come from? There are only two possibilities.
In order for the water to survive, it either has to be embedded deeply enough in rocks that it isn't melted and evaporated, or it has to come to Earth after it forms.
Was our planet originally formed from much wetter rock than the scientists had believed? Or were the oceans delivered to the Earth much later, from somewhere else? Initially, delivery seems the most likely possibility. Far out, beyond the orbit of Neptune,